Hi again, Captain Peter Cutsey with another of my online briefings. Today we're going to discuss circling to land. There is quite a bit to talk about for this particular topic, so I'll be breaking down the videos in different parts. This is part one. We're going to be using Abu Dhabi with the localizer approach to runway 13 right, circling north. And we'll assume that the first officer is going to be flying because he or she will be on the inside of the turn, which will make it easier for that kind of maneuver. Let's just have a quick look at the approach in Abu Dhabi that we're going to be doing. So a localizer approach to runway 13 right. That's what it looks like. And there's the vertical profile. The circling minimums for Class C aircraft, 850 feet. The MSL, 767 feet above the airport or above ground. We'll be using all references with respect to AFE, airport field elevation, and in Abu Dhabi's case, it's 83 feet. We're going to use 1,000 feet above airport elevation rather than the published lower minimum. So let's get right into discussing how to set up the aircraft. We're going to start with setting up a 2.5 nautical mile circle around the approach runway, which is runway 13 right, and a 2.5 nautical mile circle around the landing runway, plus an abeam radial, 90-degree abeam on the north side for runway 31 left. Let's go right to the fixed pages. I've got a picture of the airport, and I've already set up the ILS or localizer for runway 13 right. So we're looking at it now, and we will actually insert a 2.5 nautical mile ring around the approach runway. So let's do that. So there you go, 2.5 nautical miles, because that is well within the confines of TERPS, which is far more restrictive than PANSOPS. This is a PANSOPS airport, so we're well within the confines and the legalities for circling to land by going to 2.5 nautical miles on the north side of the runway. Fixed page 2, runway 31 left. "90 degrees, 036 at 2.5. So we have references for visually placing the aircraft as a guide to those points when we are actually circling to land. The 90-degree abeam is where we'll start our timing, and for circling to land at 1,000 feet, it's a 30-second timing in nil wind conditions downwind. So we've set up the fixed pages. Now we'll go and make one more adjustment to the procedure by designing a point to the northwest that is outside of the top of descent point. We're still on the plan view to make it easier to look at it. Here is the approach plate. There's suck off, And Sokoff happens to be the final fix, which is the descent point. So we want to actually trigger the pilots to begin doing 8 items, and we use 2 nautical miles prior to the descent point. So we're going to build a point here at Sokoff -2. So that's what we did. If you look over here on the legs page, Sokoff 01 is 2 nautical miles to the northwest. So there's Sokoff, and there's the point that we designed. We did that by putting in line selecting Sokoff to the scratch pad and /-2. And the FMC actually named it Sokoff 01, SOK01. So now we're set as far as the for the approach and circling to land. Go to a PowerPoint, incidentally, which accompanies all of these MP4 files in my Google library, Google Drive library. So we've set up the FMS. Let's have a look at a circling to land overview. This is how to set it up. The yellow tab here, which we have just done, and how to actually fly it in steps 1 through to step 8. This works well. We've been using this for many years worldwide, and to very, very effective. So you'll actually be able to pause the video and look at each step and study as we go. Flying the maneuver be configured at flaps 5 speed prior to the final descent point. When we go into the simulator shortly, we'll be downwind on vectors, and we will start to take flap and then turn base and then final, and we'll fly the approach from the north side downwind vectors. 2 nautical miles prior to the descent point, ensure that the MDA is set, rounded up to the next 100 feet. We are going to use 1,000 feet above airport elevation. Airport elevation is 83 feet MSL. We'll be using 1,083 feet, rounded up to 1,100. So 1,100 is what we'll be setting on the MCP in the procedure, and 1,083 is what we have set on our PFDs. There we go, 1,083. And notice we have a glide slope flag. Remember what I said initially, we can't do an ILS approach or an EN approach because those maneuvers have glide paths, and we'll be leveling off much sooner than the glide path minimums because we are executing a circle to land. Therefore, we must not use any approach with the glide path. So the glide path is off the air, and we'll be using the localizer approach, but we'll be actually using LNAV, VNAV for the lateral vertical modes for this approach in an RNAV environment. Ensure that we are in VNAV path, ensure that RMP versus AMP is as required. And if we have a look at that now, the RMP required is 1.00, and our actual is 0.03. So we are well within the legal limit to execute this approach. Then in our maneuvering, this is all at 2 nautical miles. So set MDA, ensure VNAV path, ensure RMP versus AMP as required. Gear down, flaps 15, speed brakes armed, open the speed window and set flaps 15 speed. So basically 7 items. When level at MDA and landing runway is visual, select altitude hold. Then set the missed approach altitude on the MCP. In today's case, there you have it, 4,000 feet. Then pre-select your heading bug to the runway approach runway track, in this case, less 45 degrees. Don't preset the bug until just before reaching the 2.5 nautical mile circle. Of course, the reason being is in the event that you lost LNAV, you don't want to be turning the airplane. Remember, this is a visual maneuver using the auto flight systems to assist. The autopilot, auto throttles, LNAV, VNAV, but it's a visual maneuver. Important. All right. So we're going to pre-select the heading bug to turn downwind 45 offset. The 45 offset for a track of 126, offset north is 081. And we'll make a small correction to 081 to track 081 by using prog 2/4, which we'll talk about shortly in this briefing. And then once your wings are level on a heading of, let's say, 086 for our wind situation today, to give us a track of 081, when wings are level, we commence the timing with a correction to the timing depending on the headwind or tailwind. And that's what we have here. So you take half the component. In this case, it'll be a tailwind component because the current wind at the field today is 220 degrees at 20 knots. And when we look at prog 2/4, we'll find that the tailwind component is 14 knots. Half of that is 7. That 7 will apply to the 45-second still air timing. And because it's a tailwind, we will subtract. So once wings are level on the track of 081, we'll commence a timing for 38 seconds. Then we'll turn downwind to parallel the runway track. And with the wind today, we'll have a 90-degree crosswind from the right at 20 knots. And using the little formulas I gave you in other briefings, basically 1/3 of the wind speed in lower levels is a maximum drift. So 7 degrees, so we'll actually turn to a heading of 126 plus 7, which is 133. So when we turn to 133, we'll be tracking 126 downwind. When downwind, and not later than abeam the landing runway, we'll select landing flap. And VREF, in this case, landing flap will be flaps 30, set VREF 30 plus 5. Then call for the landing checklist. When the aircraft symbol is halfway through the fixed page radial, commence your timing, corrected for headwind, tailwind, in the same way that we made the correction for the 45 off. In this case, we have a 90-degree crosswind, so we don't have a headwind or tailwind, so we'll be using the full timing of 30 seconds before the base leg turn. When timing is up, turn 90 degrees towards the track extended center line and start a 250 feet per minute rate of descent using VS. Now remember, when you select VS on the MCP, the window will actually be able to be, you'll be able to select a vertical speed because the altitude you've got set on the MCP is higher than your current altitude. Remember, we set the missed approach altitude quite a ways before we got to this point. So you'll be able to select a rate of descent of 250 feet per minute. If you hadn't selected your missed approach altitude, you wouldn't be able to actually use vertical speed. In any case, when the poppy is usable, disengage all AFDS systems and manually fly the airplane to stay on the poppy. Don't start your turn to final until the 30-second trend vector touches the extended center line. Remember, the heading you turn to on base leg was 90 degrees to the runway track, 216. When the trend vector touches, then turn the aircraft to keep the tip of the trend vector on the extended center line. That'll roll you wings level on final beautifully. This is a visual approach, so don't be focusing all your attention on the trend vector. You're in and out, in and out, in and out, in and out for whatever you're doing as far as airspeed, bank, and flying the airplane. So use the trend vector judiciously, but you'll find it works very beautifully. In the event of a go-around, you turn towards the airport and follow the missed approach procedure for the IFR procedure flown. In this case, the IFR procedure flown is a localizer, 13 right. Suggestion: stay at flaps 15 in the go-around until turning on course. This will help minimize the radius of turn to stay within the confines and restrictions of PANS-OPS. In this case, this is a PANS-OPS airport. And if you heard me mention before, I talked about TERPS. TERPS is the FAA requirement and military airport requirement, which happen to be more restrictive than PANS-OPS. You'll find that the 2.5 nautical mile downwind positioning will keep you within the most restrictive TERPS restrictions. All right. I took some pictures of an approach I did, and we'll talk about them step by step in this video before going into the airplane and actually flying the approach dynamic. Here we are downwind, 3,000 feet on vectors. We're using the autopilot. We've got Command A engaged, and the FMA indicates MC speed, heading select, and VNAV path. The controller was very smart. He gave the pilots heading of 300, knowing that that would allow them to track 306, which is parallel to the approach course of 126. You can see the wind on the nav display, 220 at 20 knots. And remember my little formulas from previous videos at 90 degrees in the lower levels, 1/3 of the wind speed is the actual drift. At this point in the approach, you would actually now call for flaps 1, and the flaps 1, we would be at the flaps 1, I should say, in this slide. As you can see, we're flying at flaps 1 speed. Once you turn to a base leg, you would call for flaps 5 and set flaps 5 speed, which you can see here. Once you're cleared for the approach, you would arm LNAV. We've got it armed, and we're actually in the turn. There's a 30-second trend vector. And once you have LNAV engaged, set the heading bug to your runway track, which we have done, which is 126. We're at flaps 5 speed. Approaching the top of descent, that 2 nautical mile point that we created. Here it is here, SOK02. So now we are preparing ourselves for the 8 items that we're going to do when we reach that 2 nautical mile point. Make sure that your legs page reflect the fact that you have a glide path. Here we have it, glide path 3 degrees. We are legal to do this approach using VNAV. Now that's a requirement. So here we are now, 2 nautical miles prior to top of descent. There's the top of descent point, and it happens to be the final approach fix. So we've got 2 nautical miles to get ready, and we have 8 items. Here they are listed down here. We want to set MDA, round it to the nearest 100 feet, which is 1,100 feet. We want to make sure we're in VNAV path. RMP, AMP is within limits. Gear down, flaps 15, speed brakes armed. Open the speed window, set flap 15 speed. If you follow these steps, 1 through 8, you'll find that you'll be perfectly set for a descent at the top of descent. Here's what it's going to look like when we look at it. You're going to get a message at that point, 2 nautical miles prior or somewhere close to that, reminding us that we should set a lower altitude. Of course, we've got to set a lower altitude on the MCP. So set MDA, 1,083 rounded up to the nearest, to the next 100 would be 1,100. There it is, set. Confirm VNAV path, confirmed. Confirm RMP versus AMP, confirmed, within limits, actual navigation, performance 0.04. Gear down, the gear is in the process of being lowered and the gear is down. Flaps 15. Speed brakes armed, we'll come to that with the picture in the future. In any case, open the speed window and set flaps 15 speed. Done. And now observe the glide path on the NPS scales. On the PFD, here it is here, and on the ND, here it is here. So that's why you have these lovely tools on this beautiful 737. So there's the speed trend vector coming to flaps 15. Perfect. Perfect. Down here, we actually have tuned the localizer, and we're going to actually confirm that our map is good in a second. Just follow me through on this. So this is important. Check map integrity. This is called airmanship. So we just quickly selected approach on the EFIS panel. We're right on the localizer. So our map is correct. We can continue using our map. Now, confirm descent begins. Their descent has begun. There is the NPS glide path and the NPS localizer. So we are right on profile. Radio altimeter alive. That is important, and it should be in your SOPs as a verbal call. You are always checking barometric altitude against the radio altimeter because of temperature changes, etc. When we actually fly the approach later, we'll talk about the VSD and the importance of using it if you have it on installed on your aircraft. There we are, established in the descent at 900 to 1,000 feet per minute. And we see the runway, there it is. Okay, that's runway 13 left, that's runway 13 right. So minimum, check altitude hold. You may go into altitude acquire depending on the FMC update that you have in your airplane. In any case, altitude acquire, then altitude hold. Ensure that you select altitude hold. So we have altitude hold selected. And now the next step immediately is to set missed approach altitude, in this case, 4,000 feet. Remember what I said about selecting a vertical speed descent later, that we're going to be at 1,100 feet. And if the altitude of the MCP is set above 1,100, we'll be able to use vertical speed later. Important. And once we got to the 2.5 nautical mile ring, we began our turn to the left to track 081. There is Prague 24, tailwind, 14 knots. That's what we were talking about. So half of that is 7. So 7 taken off of the timing of 45 seconds is 38 seconds. So that when we actually fly it later, that's what we'll be doing. Crosswind, 14 knots. And using the other formulas I showed you in previous videos, we're looking at a 5 degrees of drift, and we're going to drift left. So we're going to actually turn to a heading of 086 to track 081. So we'll do that. And then when the timing is up, we'll turn to the right downwind, and which we did. And in this particular picture, we're downwind and we've selected landing flap, and we're going to set VREF 30 plus 5. And we're just coming up to a beam, and when the airplane symbol is halfway through the beam line, we'll start our 30-second timing. And at 30 seconds timing, we'll start our turn to the right to 90 degrees, which is 216, and start down at 250 feet per minute. And that will be coming up on a future video. That's enough for now, and see you in the next video where we'll continue this briefing, and then in the following part we'll go and fly it. Thank you for watching.